Hey, hi all, very good evening. Thanks for joining with me this evening. Hope you're all doing good. Welcome to day two sessions on Python programming. So 30 days Python programming. So master 30 Python in 30 days. Welcome to day two of a program Master Python in 30 days. Thank you all for joining with me. So we can start off this session now. We can start this session now. Thank you all for joining with me. In the last session, we had a discussion on introduction to Python programming. So what Python programming is and history of Python programming and features of Python programming and then keywords. The history of Python programming, Python was developed by Guido van Rosen and Python was developed in the year 1989 and Python was officially released in 1991. So features of Python programming. Python is open source programming language. Python is dynamically typed language. Python is platform independent language. Python is interpreted language. And as well, Python have exception handling techniques. And Python is easy to learn and easy to understand. And Python supports object-oriented programming concepts that we discussed in the last session. And the keywords also we had a discussion. Keywords are the reserved words which have special meaning. The keywords are used to write meaningful instructions to the computer, and keywords should not be used as identifiers. In Python, we have around 35 keywords. To view all the keywords, we have a simply import keyword and print of keyword.kw list of all the keywords will be returned. And then in the last session, we had a discussion on identifiers, name of a variable, name of a class, name of an object, name of a function is called an identifier. And identifiers are used to write meaningful instructions to the computer that we had a discussion yesterday. The name rules of identifiers. Identifiers should only contain alphanumerics and an underscore only. Identifiers should only start with a character or an underscore. Keywords should not be used as identifiers, and white space is not allowed in identifiers that we discussed in the last session. And the comments also, in Python, comments are written with hash. Whatever we write after the hash symbol, that will be considered as a comments. Whatever you write after the hash, that will be considered as comments. In Python, we cannot comment multiple lines at a time. Each line should be commented separately. Comments are used for better readability that we discussed yesterday. And as well, print function also we discussed. Print is an inbuilt function used to print values, variables, and as well text. That what we discussed so far in the last session. Okay, that we discussed so far in the last session. Now, in this evening, we'll be starting with variables. In this evening, let me give you idea on variables. The very first topic is variables. I'll be taking a markdown cell. I'll be putting heading variables. What is a variable? Basically, variables are very important to write programs. If you want to write any program, for sure you need variables. What is this variable in Python? In Python, variable is a name used to store data in a memory, or variable is a data container, you can say. In simple words, you can think of it as a container or simply a box that holds some information. Variable is a name which is used to store data in a memory, or in simple words, it's a data container that holds information. Let me write some description about variables. So variable is the name. Simply variable is a name used to store data in memory. And other definition I'll write. Variable is the data container Variable is a data container that holds information. Variable is a data container that holds information. That is what about variable. Or a simple definition, a variable is a label that refers to a value. Variable is a label. A simple definition, I'll write. A variable is a label that refers to a value. Variable is a label that refers to a value. So how to create a variable? There is no specific syntax in Python to create variable. There is no specific syntax to create variables in Python. There is no specific syntax. In other programming languages, for sure we need to write like, so int of A on int B on semicolon something, and something like float C used to write like this. In other programming languages, we need to define variables like this. But in Python, there is no specific syntax to create variables. Directly, you can take some variable name, something like area is equal to 40. So meaning that this is simply how you create variables. When you assign a value to some name, some name, then variable is going to be created. The moment you assign a value to a name, then variable is going to created. Very simple. There is no specific syntax in Python to create variables. So simple syntax, let me write how to create a variable. Let me write, there is no specific syntax, but let me tell you how to create variable. So simply you can write, I'll be writing in markdown cell, raw cell, how to create a variable. So variable name is equal to, simply we can give a value. Variable name and simply can give a value. So simple examples, x is equal to 10 is a variable, x is a variable, 10 is a value, x holds a value 10. 10 is assigned to a variable a. 10 is assigned to variable a. X is a variable, 10 is assigned to a variable a. X is a name. When you assign a value, that becomes a variable. Okay. Simply like name equal to, if I write Datateach, then this is a variable. This is a variable. Or simply price is equal to 900. That is a variable. So this is how we can create variables. There is no specific syntax to create variables in Python. The moment you assign a value, then simply the variable is going to be created. Here, in this case, x is a variable. X is a variable name. 10 is a value. 10 is a value. In this example, x is a variable name. 10 is a value. Python stores 10 in a memory and x points to it. Simple point I'll write. Python stores 10 in memory. Python stores 10 in a memory and x points to it. Python stores 10 in a memory and x points to it. So whenever you want 10, you can write x so that 10 will be returned. So key features of variables in Python. The very important key features of variables in Python. So no need to declare type, dynamically type. Python automatically detects the type. Python automatically detects the type. For example, if you write x is equal to 10, automatically detects and it wants as an integer. Okay. So if I write x is equal to in single quotes hello, Python automatically detects its type, that one as a string. No need to declare the data type. It is dynamically typed. So no need to declare the type. And dynamic typing. Dynamic typing meaning that you can change value at any time. You can change dynamic typing. Let me write about variables. Dynamic typing. You can change values at any time. A is equal to 5. Then print of A, that is 5. You can change the value of A at any time. Just I'm writing Python A is equal to print of A. If you write, that is Python. So in such a way, we can change value at any time, dynamic typing. And those are case sensitive. Python variables are case sensitive. Python variables are case sensitive. Name is equal to, I have written Datateach, and other one I'll be writing name is equal to, see here, print of, if you write print of name and print of, both are different here, NAME, both are different. Though spelling is same, though spelling is same. You see here, spelling is same, meaning is same. Here just one character is differed. One character is difference. So those two variables are different ones. Those two variables have different values. So this is name, meaning is same and spelling is same, but one uppercase character, simply both are not same. Python variables are case sensitive. Python variables are case sensitive. And variable name rules as same as identifier name rules. Variable name rules are same as identifier name rules. Allowed variable names, let me show you. Simply if I write my name is equal to data. So this is a valid one. This is a valid one. A is 1, something like A is 1 equal to 35. This is also a valid one. And if you write underscore total is equal to 34, this is also a valid one. These are valid variable names. These are valid variable names, which are not allowed. Let me show you. Yesterday we had a discussion, right? Identifier name rules. For example, if I write one name is equal to, simply, if I write data dish, it is not allowed. So variable or identifier name should not start with a numeric value, should start with a character, should only start with a character. Simply if you write my hyphen name, if you write my hyphen name is equal to, it is invalid because hyphen is not allowed. Hyphen is not allowed, it is invalid. Okay. So the best practices, which is important for interviews. Okay. So best practices, let me write for interviews on variables. In Python interviews on variables, let me write some best practices important for interviews. Best practices, let me tell you. Use meaningful names. The very first one, use meaningful names. Use meaningful names. And second one, use lowercase with underscore. Second one, use lowercase with underscore. The best practices. I'll give you examples for each and every one. See, the very first one, use meaningful names. Use meaningful names. For example, student name is equal to something Raj. Like this, it is a valid and meaningful name. So something like A is equal to, if I write Raj, no one understand what it is. Not meaningful. Though it is correct, it is not meaningful. This is meaningful variable name. Always prefer writing meaningful variable names, descriptive variable names that should give a good meaning. Okay. So marks is equal to something like marks is equal to 90. It is a meaningful one. It is a meaningful name. So something like x is equal to 90, no meaningful, not meaningful. So always prefer meaningful variable names. Best practices for interviews and writing clean code. For writing clean code, always prefer always prefer best practices. Write meaningful names. The very first one, write meaningful names. Write meaningful names always. It's a good practice always. Okay. And then use lowercase with underscore. Use lowercase with underscore. For example, total total marks is equal to 789 out of 1000 something. This is a using lowercase with underscore. Better always use lowercase with underscore. Okay. Best practices for variable names. Always use meaningful names. Use lowercase with underscore. Okay. So and then so multiple variables, assign multiple values, multiple variables, multiple values, multiple variables. Assign multiple values, assign multiple values, meaning that simply a comma b comma c equal to simply 10 comma 20 comma 30. We can assign multiple values to multiple variables. We can assign multiple values to multiple variables. 10 is assigned to a, 20 is assigned to b, 30 is assigned to c. So if you write a comma b comma c is equal to 20, 30 and 40, 20 is assigned to a, 30 is assigned to b and 40 is assigned to c. In such a way, the items are gonna be assigned. So if you want to print them, print of a comma b comma c. See, a is 20, b is a is 10, b is 20, c is 13. So or simply a comma b comma c. If you print, these are the values. Print of, if you write a, that is 10. Print of b, that is 20. Print of c, that is 30. Like this, we can assign multiple values to multiple variables. Multiple values to multiple variables. This is how we can assign. Okay. Multiple values we can assign to multiple variables. And then we can assign same value. We can assign same value to multiple variables. Assign same value to multiple variables. Assign same value to multiple variables. Simply x is equal to y is equal to z is equal to 45. Then same value will be assigned to all three variables. So 45 is assigned to 45 is assigned to x, 45 is assigned to y, 45 assigned to z. So x, y, z all will be assigned. 45 is assigned to all three variables. So if you want to print, just you can print like print of x comma y comma z, same values you can see. Okay. So in real life, analogy, if you want to understand, it is a labeled bottle something. Think of a variable like a labeled bottle. The bottle name is variable and water inside is a value. Very simple. Think of a variable like a labeled water bottle. Labeled water bottle means on a water bottle we have a label or a sticker, right? The bottle name is a variable, water inside is a value. Okay, so quick summary of these variables, a quick summary. And before to that must follow is uh, you know use always a meaningful names, very important. And use snake case. Use snake case. In interviews people ask you what is snake case. Use snake case when you're creating variables. When you're creating variables, use snake case. Python follows snake case. Let me tell you what is that snake case. Python follows snake case, meaning that simply I'll tell you a snake case. First name, first name equal to something. First name is equal to something Satya. Something like total salary is equal to some 1 lakh. And so something like is active user something like is equal to something true. Like this, use snake case. Snake case means lowercase with underscore. Snake case is nothing but lowercase characters. Snake case means lowercase characters with snake case means a lowercase characters with an underscore. Okay, lowercase characters with an underscore, which is called snake case. Always follow a snake case. Always follow a snake case for variable declaration. Okay, hope you understand. And do remember also, always prefer snake case, and those are case sensitive. And avoid keywords. Don't use keywords. Don't use keywords as a variables. Don't use keywords as a variables. So don't use keywords as variable. For example, if is a keyword, if equal to 34, this is invalid. You shouldn't use keywords as a variable. And constants, when you're creating a constant naming, special convention, when you're creating a constant, something like pi is equal to 3.14. Some constants when you're taking, constants are written in uppercase. Better always practice, better always make a practice of, better always make a practice of writing constant with uppercase. Constants are written with constants are written with uppercase. So pi is equal to 3.14, or something like max underscore limit is equal to something 100. Like this, when you want to create some constant variables, if you don't want to change them, if you don't want to change them, so a better convention is write them in a uppercase. Okay, and avoid single letter variables. Always avoid single letter variables. Avoid single letter variables like a is equal to 10 and something b is equal to 45. Like this, better you avoid single line variables. Always good practice is simply length is equal to something 34 and some width is equal to 67. Like this, better always give more descriptive names. And no space is allowed. No space is allowed, meaning that in variable names, something like area space width, if you write area space width is equal to 34, this is invalid because no space is allowed. Because no space is allowed. So instead of that, area underscore width, if you write, then it is valid one. Use always a snake case. Use meaningful names. Avoid keywords and special characters. and constants use uppercase, and keep names clear and readable. A quick summary I'll write here. Quick summary I'll write. Always use snake case. Use snake case. Use meaningful names. Use meaningful names. And then avoid keywords. Let me write. Use always snake case variables. Variable names while you're creating, always use snake case. Use meaningful names and avoid keywords and special characters. Avoid keywords and special characters. Avoid keywords and special characters. And then constants, always use constants uppercase. Use uppercase for constants and keep names clear and readable. Always keep names clear and readable. So these are the things should be keep in mind. Okay. So simple tip, entry level simple tip I'll write. Good naming is equal to, simply I'll write interview tip, simply good naming. Good naming is equal to clean code is equal to, for sure you will be a better developer. Good naming, clean code, better developer. If you write good naming conventions, if you follow good naming conventions, you can write a clean code. If you write a clean code, you can be a better developer. Okay. So always keep in mind, use snake case. Snake case means lowercase characters with an underscore. Always use meaningful names. Avoid keywords and special characters. Constants use uppercase. Keep names clear and readable. Avoid writing single character variables. Okay. Good naming, clean code, better developer for sure. Okay. That's all about variables. That's all about variables. Just we had a discussion. The very first topic for this evening, the variables, we had a discussion. Right. So now data types in Python. For this evening, the second topic is data types in Python. So let me put a heading, data types. So what is a data type? In Python, data types defines the type of value a variable can hold. In simple words, data type tells you what kind of data it is. Data types define the type of a value a variable can hold. Simply, they tell Python what kind of data you are working with. In simple words, this data type tell Python what kind of data you're working with. Just it tells our system that what kind of data we are working with. Okay. So data types simply, let me write simple definitions. Data types define the type of value a variable can hold. So simply it tells Python what kind of data we are working with. It tells what kind of data it is. Very simple words, no complex definitions. Okay. So let me tell you what are the different data types we do have. What are the different data types we do have? Let me show you. What are the different data types we do have in Python? So we have numeric data type and text data type, that is string. We have numeric. So let me write here all the data types available. So the very first one is numeric data type. The very first one is numeric. In numeric, we have integers. We have integers and we have floating point data, and we have complex data, complex numbers. In numeric data types, we have integers, floating point, and complex numbers. Integers meaning that whole numbers. Integers means whole numbers. Floating point means decimal numbers. Complex means real plus imaginary numbers. Okay. So let me write here. Integer meaning that whole number. Integer meaning that whole numbers. Integer meaning that whole numbers. And then floating means decimal numbers. And the complex means real part plus imaginary part. Real plus imaginary. Those are the complex numbers. Okay. So these are the three types of numbers. The whole numbers, 20 is a whole number, minus 40 is a whole number. These are examples for integers, and simply 20.89 and minus 89.267. These are the decimal numbers. Those are the floating point numbers. And then complex numbers, you can see 10 plus 8j is a complex number in which 10 is a real part, 10 is a real part, and 8 is the imaginary part. 10 is imaginary part, and j is to represent imaginary part. In normal mathematics, we use I, 2 plus 6i. I is to represent imaginary part in normal mathematics. But in Python, we use j to represent imaginary numbers. Imaginary part, to represent imaginary part, we use j. Okay. And then second one, string data type, text data type. The second one is, I'm sorry. So the second one is text data type. Text, or we can call it as a string. In text data type, we have string only. In text data type, we have a string. String meaning that anything enclosed with a single quotes or double quotes, which is called a string, which is enclosed with a single quotes or double quotes. We can use a single quote, something like Python, that is a string. String is a collection of characters. We can use double quotes also, something like programming, that is a string. Single quotes and double quotes are used to represent strings. So that is a second data type, that is text data type. Okay. And then other one we have collection data type or sequence data type. People used to call it as a collection or a sequence. Sequence data type or collection data type, or simply we can call it as a sequence also. In sequence data type, we do have list, and tuple, and then set. Set is also sequence, and dictionary, and as well string is also a part of sequence data type. String is also a sequence data type. Okay. String is also a sequence data type. And then other one, we do have set data type. In this one, set and as well frozen set also we have. Set and frozen set is another data type. And then we have another one, which is Boolean data type. In Boolean, we have true or false. True and as well false. We do have true and false. And other one, we have mapping data type. Another one is mapping, in which we have dictionary. In mapping, we have dictionary. These are the data types available in Python. These are the data types available in Python. The very first one, numeric data type. In numeric, we have integers, floating point, complex numbers. The whole numbers are called integers. Decimal numbers are called floating point. Real plus imaginary part, that is complex numbers. In text data type, we do have a string. String is a collection of characters or a sequence of characters. Okay. So enclosed with either single quotes or double quotes as well. The next data type is collection data type or sequence. A sequence of items separated by comma. A sequence of items separated by comma. A sequence of items separated by comma, that is sequence data type. Okay. So, and then in sequence, we do have list, tuple, set, dictionary, and string. So in set, and again, another data type is set, in which we have a set and as well frozen set. Then Boolean, true and false we have. And then mapping data type, we have a dictionary. In mapping, we have dictionary. In mapping, we have a dictionary. These are the data types available in Python. So let me list down all these. The very first one, integer data type, in which we have the very first one, numeric data types. The very first one is numeric, in which we have integers, meaning that whole numbers. And the second one, in numeric integers, and then floating point values, meaning that decimal values, decimal numbers. And third one is complex numbers. Complex numbers means real part plus imaginary part. This is numeric data types. And then the other one is string or text data type. In text we do have string only, a string only, sequence of characters, written with single quotes or double quotes. And then collection data type or sequence data type. Sequence or collection data type. I will share these notes with you. That's why I'm writing here, will be useful for the reference. Sequence or collection data type, in which we have list, tuple, set, dictionary, and string also. And other one, set data type. In set, we have set and frozen set. We have set and frozen set. And then Boolean data type. In Boolean, we do have true and false, true or false. And other one, the mapping data type. Other one is mapping. So in mapping, we do have dictionary only. So these are the data types available. These are the data types available in data types in Python. So just you can have a look. These are the different data types available in Python. Okay. Just we had a discussion. Now we'll see one by one. We'll see one by one what it is and how it works. And these are stuff we'll try to see now. So the very first one, we'll talk about the very first one, numeric data types. The whole numbers are integers. The first one, the whole numbers are integers. If I write a equal 67, that is a integer, simply that is a integer. And something like b equal to, if I write negative number, it is also a whole number. Those two are examples for integers. Those two are examples for integers. If you want to check the data type, print off. If you want to check the type of data, or else the data type of a variable, data type of variable a is, so you can use a method type. Type is a method or inbuilt function. Type is a method or inbuilt function. Type is a method or inbuilt function which returns the data type of a variable. So let me write another one. Data type of a variable b is, I'll be writing type of b. You see, class integers. The data type of variable a is class int. Class represents data type. Class represents data type. So class integers. These are whole numbers or integers. The next one in numeric, the first one integers. And floating point, if you want to see the floating point values, something a equal to 45.89, something b equal to 32 minus 32.67 something. So those two are floating point data. Those two are floating point data. Those two are floating point data, you can see. You can see data type here. And then complex numbers, you can see complex numbers. I'm sorry. Complex numbers you can write a equal to 2 plus 9j, real part and imaginary part. B is equal to minus 4 minus 8j something, all negative ones. C is equal to something, I'll be writing only imaginary part 6j. These are the possible cases for complex numbers. These are the possible cases for complex numbers. These are the possible cases of complex numbers. Then if you check printing the data type of variable C, see all are complex numbers. These are the possible cases for complex numbers. These are possible cases for complex numbers. So just we are done with numeric and floating point and complex numbers. Okay. Just you are done with numeric, and we do have a strings concept separately, and then list, tuple, set, dictionary. We do have separate topics. For now, we'll be starting with operators. After the operators, we'll start with string data type. What is a string? How to define a string, and how to access string characters, and indexing, slicing, string methods. These are stuff we can discuss. Before to that, let me give you idea on operators in Python programming. So let me put a heading operators. What an operator? What is an operator? What is an operand? So let me tell you what is an operator. We'll talk about an operator. So for now, the topic is operators in Python. Operators. So for example, A is equal to 20, B is equal to 50. If you write A plus B, so plus is here an operator, plus is an operator here. Plus is an operator. A is operand, A is an operand, B is an operand, Operand, or we can call it as a variable also. Okay. Operand or variable also we can call. Operand or a variable. We can call this one operand or variable. So this operator performs operation on variables or operands. In operator, this is a plus operator. For example, if we write A asterisk of B, meaning that A into B. So this asterisk performs multiplication operation on two variables A and B, or two operands A and B. Okay. So an operator is a simply a symbol that performs an operation on variables or operands. Okay. So in Python, we do have different types of operators. The first one is arithmetic operators. Most of you people know arithmetic operators. The first one is arithmetic operators. First one is arithmetic operators. And most of we people know what are the arithmetic operators. Plus, addition, subtraction, multiplication, division, addition, subtraction, multiplication, division. And then we do have floor division also, and modulus also, and exponentation also. We'll discuss one by one. These are all arithmetic operators. There are around 7 different types of operators: arithmetic operators, and then assignment operators. We do have assignment operators. Assignment operator is simply equal to is an assignment operator. Third one is relationship operators. Third one is relationship or comparison operators. Relationship or comparison operators. These relationship or comparison operators are greater than, less than, checking for equality, greater than or equal to, less than or equal to, not equal to. These are some different relationship operators or comparison operators. And the next one is logical operators. The next one is logical operators. We'll discuss one by one in detail. Logical operators. These logical operators are logical and, logical or, and logical not. And the next one is membership operators. The next one is membership operators. The next one is membership operators. Membership operators are simply in, not in. In and not in, those are membership operators. Then identity operators. The next one is identity operators. The next one is identity operators. The identity operators are used to check memory location. Is and is not. Is and is not are identity operators. The next one is bitwise operators. We have another one which is bitwise operators. Bitwise operators. What are the bitwise operators we have? Bitwise and, bitwise or, bitwise not, bitwise not, bitwise XOR, bitwise left shift, bitwise right shift, and we do have some bitwise operators in Python. Totally, there are around 7 different operators we do have in Python. Let us list down one by one. Let us list down one by one operators. Operators are used to perform operations on operands. Operators are used to perform operations on operands or variables. So the very first one is arithmetic operators. The very first one is arithmetic operators. The second one is assignment operators. And third one is relationship or comparison operators. Relationship or simply comparison operators. Relationship or comparison operator. Fourth one, logical operators. The logical operators. And then fifth one is membership operators. Membership operators. And then sixth one, identity operators. And then seventh one is bitwise operators. So these are the different types of operators we have in Python. So for this evening, we'll talk about arithmetic operators. So let me give you idea on arithmetic operators. I'll be putting heading arithmetic operators. Arithmetic operators. The very first one, we know addition, right? Addition, the symbol is plus symbol. Addition is plus symbol. The second one is subtraction. The symbol is minus. And third one, multiplication. The symbol is star. And the fourth one, division. The symbol is this. And the fifth one, floor division. The floor division is 2 backslashes. And the sixth one, modulus, which returns reminder of a division. And the seventh one, exponentation. Exponentation means power of. The symbol is double asterisk. So let us see one by one. Let us talk about arithmetic operators. The very first one is arithmetic operators. Let me give you idea on arithmetic operators. Arithmetic operators. So for example, addition, we know A equal to 10, B equal to something 3. Plus operation, we know A plus B, that is 13. And subtraction also, we know A minus B, that is what? 7. And then multiplication also, we know A into B, that is simply 10 into 3, 30. And division also, we know A by B, division, we know division A by B, that is 10 by 3. So 3 and 10, 3 3s are 9 and 1.0 and 3 3 3 3 and so on. The output is 3.333. Okay. So now floor division. Floor division is, the symbol is floor division. Floor division or integer division. Interviews people may ask you floor division or integer division. Floor division or integer division. So A floor division of B, meaning that, so 10 floor division of 3, 3 and 10, 3 3s are 9, 1.0 and 3 and 3 and 3 and 3. So this floor division or integer division returns integer part of a normal result. Integer part of a result. What is the integer part of a result? That is 3. So this decimal part will be truncated. This decimal part will be truncated. Output will be this one. Output will be integer part. So for example, 25 by 25 floor division of 3. 25, 3, 3 8s are 24, 1.0, 3 3s are 9, and so on. Output will be 8.333 and so on. But if I write 25 by 3, 25 floor division, then output is 8 only. It considers only integer part. That is why I call integer division. Floor division, the name why it became floor division. Flooring means lower bounds. Floor means lower, seal means upper. Floor means lower, ceiling means rounding off to upper bounds. Ceiling means rounding to upper bounds. Flooring means rounding to lower bounds. Okay. So 25 floor division of 3, which returns 8, meaning that it returns integer part of your division. It returns integer part of your division. That is what floor division, integer division. The next one, the next one is modulus operation. The next one is modulus. The modulus meaning that A modulus of B, for example, 10 modulus of 3. 10 modulus of 3 meaning is 10 modulus of 3 meaning is 10. 10 modulus of 3. See here 3. 3 3s are 9. What is your remainder? 1. Remainder 1. So it returns modulus returns remainder. Modulus returns remainder. Remainder of a division. So modulus returns remainder of a division. For example, 29 modulus of 3. So then 29, 3, 3 eights and 3 nines or 9 threes are 27, 3. Output is 3. It returns the remainder of a division. So 29 floor division of 3, meaning that it returns remainder. See, it returns remainder. Simply, it returns 3 here in this case. That is what modulus operation is. Modulus or modular division simply returns the remainder of a division. The next one, exponentation. Exponentation meaning that power of. For example, A equal to 2, B equal to 3, A exponentation of B, if you write A exponentation of B, 2 exponentation of 3, meaning that 2 power 3. Exponentation meaning that power of. Exponentation meaning that power of. Just you can see, for example, 10 exponentation of 3 if you write, meaning that 10 power 3. 10 power 3, that is 10 into 10 into 10. So that is what it is really. So there are 7 arithmetic operators. We have 7 arithmetic operators: addition, subtraction, multiplication, division, floor division, which returns integer part of a quotient, integer part of a result, and modulus, which returns remainder of a division. Modulus is which returns remainder of a division, and exponentation meaning that power of. So 2 exponentation of 3 meaning that 2 power 3. Okay. These are all different arithmetic operators. These are all different arithmetic operators we do have in Python. See, for example, A equal to 10, B equal to 3. So A plus B, 13, A minus B, you see 7, A multiplication of B, 30, A division of 3, it returns the quotient, A floor division of 3, A floor division of something B here, A floor division of B, which returns, see here, it returns only integer part only. Floor division returns integer part, or we can call it as integer division. A modulus of B, which returns remainder, meaning that here 10 modulus of 3, the remainder is 1. And A exponentation of B, that is 1000, meaning that 10 cube, power of. Exponentation means power of. So exponentation means power of. These are the different arithmetic operators we do have in Python. In tomorrow's session, we will be talking about all the other operators, relationship operators, assignment operators, logical operators, membership operators, identity operators, and bitwise operators. We will be discussing other operators in tomorrow's session. We are done with arithmetic operators. We are done with arithmetic operators in Python. Arithmetic operators in Python. We are done with arithmetic operators in Python. Then assignment operators and relationship, logical, membership, all other operators we'll be discussing in other session. And sorry, some mistake. Yeah, just give me a moment, please. 29 by 3. Where is that? 29. Yeah, here is 2. Okay, I'm sorry. So 3 of 29. So 3 nines are 27. The remainder is 2 only. The remainder is 2. Just on a overseen, I have overseen this. Simply you can correct it. So 3 modulus 29 modulus of 3, 29 modulus of 3, which is 2. Meaning that 29, 3, 3 nines are 27. The result is 2. Okay. Thank you, Nandan, for correcting. Yeah, just overseeing that. Yeah. That's all from my end today. That's all from my end today. If you have any questions, in tomorrow's session, we discuss. If you learn something good, say thank you in the chat box. Say thank you in the chat box if you like it. And in tomorrow's session, we'll be covering all other operators in Python. Thank you all. Have a great rest of your day. See you tomorrow. And YouTube chat also, if you are watching, please do say thank you if you learned something good today. In tomorrow's session, the remaining arithmetic operators, we are done. The remaining operators we will be discussing. Have a great rest of your day. See you tomorrow at 6 o'clock. We'll be discussing other operators. Thank you, guys.